In this presentation, we are going to review the fundamental trigonometric identities and using it to prove some trigonometric equations. So let's recap what are the fundamental trigonometric identities. So first is we have the reciprocal identities. So we have sine u is equivalent to 1 over cosecant u. That is because cosecant and sine are reciprocal. The same goes with the following. Cosine u is equivalent to 1 over secant u. That is because secant and cosine are reciprocal. Same goes with tangent and cotangent. The next identities is the quotient identities. So we have tangent u is equivalent to sine u over cosine u. Or we can say that tangent is the quotient of sine and cosine. We all know that tangent and cotangent are reciprocal, so we can also say that cotangent u is equivalent to cosine u over sine u, or cotangent is the quotient of cosine and sine. The next identities is the Pythagorean identities. So we have sine squared u plus cosine squared u is equivalent to 1. Now, we can derive the other Pythagorean identities using this identity by dividing all of the terms by either sine squared or cosine squared. When we divide all terms by cosine squared, the resulting equation will be 1 plus tangent squared u equal to secant squared u, while by dividing all sides by sine squared u will lead us to 1 plus cotangent squared u equal to cosecant squared u. Now let's look at some of the examples. So verified identity sine t plus cotangent t cosine t is equivalent to cosecant t. Now, there is no standard way of proving trigonometric identities. You can simplify only one side of the equation or manipulate both sides depending on the complexity of the problem. An easier way of proving is by simplifying the more complicated side. So in this problem, we can see that sine t plus cotangent t cosine t is more complicated compared to the other side of the equation. So we will try to simplify that side of the equation. So we can apply the quotient identity to cotangent t. So we can write it as cosine t over sine t, or the quotient of cosine and sine. Now, we can add the fractions. We will have sine squared t plus cosine squared t over sine t. So notice that the numerator is a Pythagorean identity. So we can rewrite the numerator as 1 over sine t. Now, we know that 1 over sine t is a reciprocal identity, which is equivalent to cosecant t. Hence, we prove the identity sine t plus cotangent t cosine t is equivalent to cosecant t. Next, perform the addition and simplify sine theta over 1 plus cosine theta plus cosine theta over sine theta. By combining the fractions, we will get sine theta times sine theta plus cosine theta times quantity 1 plus cosine theta all over quantity 1 plus cosine theta times sine theta. Now, we simplify the numerator by multiplying sine and sine and distributing cosine theta to 1 plus cosine theta. So the fraction will be simplified to sine squared theta plus cosine squared theta plus cosine theta all over quantity 1 plus cosine theta times sine theta. Notice that the numerator consists of a Pythagorean identity sine squared theta plus cosine squared theta. So we can rewrite it equivalent to 1 plus cosine theta all over 1 plus cosine theta times sine theta. We can simplify it further by canceling 1 plus cosine theta on the numerator and the denominator. That will lead us to 1 over sine theta. Applying the reciprocal identity, this is equivalent to cosecant theta. Third example, verify the identity secant x plus tangent x equal to cosine x over 1 minus sine x. Now we can choose to simplify the right side of the equation cosine x over 1 minus sine x. Notice that we don't have an identity equivalent to 1 minus sine x. But what we can do is to force it to become an identity. So how are we going to do that? We will multiply both the numerator and the denominator by 1 plus sine x. Multiplying both numerator and denominator by 1 plus sine x, that will give us the fraction cosine x plus cosine x sine x over 1 minus sine squared x. Now notice that the denominator now is an identity, which is a Pythagorean identity. So we can rewrite the denominator as cosine squared x. Now, we can split the fraction and we can rewrite it as separate fractions cosine x over cosine squared x plus cosine x sine x over cosine squared x. We can simplify both fractions into 1 over cosine x plus sine x over cosine x. Now, the first fraction can be written as the reciprocal identity secant x, and the second fraction is a quotient identity that can be written as tangent x. Hence, we prove the identity secant x plus tangent x is equivalent to cosine x over 1 minus sine x. Moving on to other trigonometric identities, we have the sum and difference formulas, that is for sine, cosine, and tangent. We also have the double angle formulas for sine, tangent, and cosine. Now let's try to apply it to this example. Rewrite sine 3x in terms of sine x. We can rewrite the angle 3x in terms of a sum. That is, sine 3x is equivalent to sine quantity 2x plus x. Now, applying the sum formula for sine, that will give us sine 2x cosine x plus cosine 2x sine x. Now, applying the double angle formula for sine 2x and cosine 2x, that will give us 2 sine x cosine x times cosine x plus quantity 1 minus 2 sine squared x times sine x. Applying the distributive property, that will give us 2 sine x cosine squared x plus sine x minus 2 sine cube x. Now, we can see that there is a Pythagorean identity. We can rewrite cosine squared x as 1 minus sine squared x. That will give us 2 sine x, quantity 1 minus sine squared x, plus sine x minus 2 sine cube x. Distributing 2 sine x to the 1 minus sine squared x, that will give us 2 sine x minus 2 sine cube x plus sine x minus 2 sine cube x. Simplifying and combining similar terms, that will give us 3 sine x minus 4 sine cube x. So we were able to rewrite sine 3x in terms of sine x. Next, we want to write cosine quantity theta minus 3 pi over 2 as a trigonometric function of only theta. Now, we can apply the difference formula for cosine. That will give us cosine theta cosine 3 pi over 2 plus sine theta sine 3 pi over 2. Now, notice that cosine 3 pi over 2 is equivalent to 0. So we can rewrite the equation cosine theta times 0 plus sine theta sine 3 pi over 2. So we can cancel out cosine theta times 0. So we only have sine theta sine 3 pi over 2. But sine 3 pi over 2 is equivalent to negative 1. So we can simplify further the equation into sine theta times negative 1, or we can write it as negative sine theta. For our last example, we want to prove sine raised to 4x is equivalent to 1/8 times quantity 3 minus 4 cosine 2x plus cosine 4x. Now, we can be tempted to just simplify the right side of the equation, but let's try to do it by simplifying the left side of the equation, which is sine raised to 4x. By applying the property of exponents, we can rewrite it as sine squared x raised to 2. Now, applying double angle identity for sine squared x, we can rewrite it as 1 minus cosine 2x over 2 squared. Applying again the property of exponent, it can be written as 1/4 times 1 minus cosine 2x squared. We will try to expand the 1 minus cosine 2x squared. That will give us 1/4 times quantity 1 minus 2 cosine 2x plus cosine squared 2x. Now, applying again the double angle identity for cosine squared 2x, that will be giving us 1/4 times quantity 1 minus 2 cosine 2x plus 1 plus cosine 4x all over 2. Applying the distributive property, we will distribute 1/4. So that will give us 1/4 minus 1/2 cosine 2x plus 1 over 8 plus 1 over 8 cosine 4x. Simplifying the expression, that will give us 3 over 8 minus 1/2 cosine 2x plus 1/8 cosine 4x. Lastly, we factor out a common factor, which is 1 over 8. That will give us 1 over 8 times quantity 3 minus 4 cosine 2x plus cosine 4x. Hence, we prove that sine raised to 4x is equal to 1 over 8 quantity 3 minus 4 cosine 2x plus cosine 4x.